Hello everyone, let's start the question. Question says that two coherent sources produces a wave of different intensities with interference which interfere. After interference, the ratio of maximum intensity to minimum intensity is 16. The intensity of waves are in ratio. Okay, so we have to find out the ratio of the intensity of wave. Suppose there is a source and there is another source. Let's say this is A and this is B. Okay, so both are producing wave and these are interfering. Okay, so the intensity maximum by minimum is given 16. Okay, and let's say the intensity of A is I1 and for B is I2. Okay, so we know that the intensity is directly proportional to amplitude square. Okay, so we can write for this, that is amplitude maximum square divided by amplitude minimum square will be equal to 16. Okay, so from what we can get, we can say that A max by A minimum will be 4. Okay, now we know that A1 plus A2. Okay, so this is the A max, and A1 minus A2, this is the amplitude minimum. Okay, and this is equal to 4. So if we apply the componendo and dividendo, then this one we can write A1 plus A2 plus A1 minus A2, A1 minus A2. Okay, and here we can write A1 plus A2 minus A1 minus A2, and so this one will be minus A1, but here minus, so this minus and this minus, the minus will be plus A2, and here we can write 4 plus 1 by 4 minus 1. Okay, so here A2 and A2, and here A1 and A1 are cancelled out. So what is left? So 2A1 by 2A2 equal to 5 by 3. So 2 again cancelled out. So now we have A1 by A2 equal to 5 by 3. Now we need to find out A1 square by A2 square, because this is we know that the intensity is directly proportional to square of the amplitude. Okay, so we can write A1 square by A2 square equal to 5 square by 3 square. Okay, and this will be equal to intensity of 1 by intensity of 2. Okay, so we can write from here I1 divided by I2 equal to 5 square, that is 25, and 3 square 9. So we have to find, we had to find this one, so we can write the I1 by the ratio of I1 by I2, that is intensity of 1 by 2 equal to 25 by 9. Thank you.
Hello students, we have a question that the angular width of a central maxima in a single cell diffraction pattern is 60 degree. The width of the cell is 1 micrometer. The cell is illuminated by monochromatic plane wave. If another cell of same width is made near it, then young fringes can be observed on the screen placed at distance 50 cm from the silt. If the observed fringes width is 1 centimeter, what is silt separation distance we need to find? So we are given the situation that we have a single silt of A and monochromatic plane wavefronts are propagating like this, and from this we are given that we have a screen, and this screen we are getting the maxima and from this minima again the intensity decreases, and we are getting the value like this of the diffraction pattern. So the angular width is given, which is 60 degree. So from here we see that this is the angular width given to us, and this is theta, and this is given angular width, that is 2 theta is given to us, which is 60 degree. Therefore theta is 30 degree for us. Now if another silt of same width is made near it, so if another we have this is A of same width near it, then young fringes can be observed on the screen placed at 50 centimeter. 50 centimeter is the capital D given to us, and we are asked that fringe width is 1 centimeter, then silt separation we are asked. So we are having two silt and the center distances are this much. So we are asked to find out this value. We are taking this value as a small d. So we need to find out this value. So we have the solution as for first minima we have formula as A width of the silt into sine theta, which is equal to n into lambda. N is the number of minima, so n we are taking 1 because it is for first minima. So we are getting the value as A into sine 30 degree is equal to lambda. Therefore lambda we are getting as A upon 2, and the value of A is 1 micrometer upon 2. So we have the value as 0.5 micrometer as the value of wavelength, that is this lambda. Now after this we will use diffraction of double silt experiments. So Young's double silt experiment we are using. For Young's double silt experiment we are having the relation that beta is equal to lambda wavelength into the distance between the screen and the silt divided by the separation, and this beta is given to us. So therefore we have the expression as 1 centimeter is equal to lambda by d upon d. Now putting the all other values in standard form, we have 1 upon 100 meter is equal to, this is 0.5 micro, that is 10 to the power minus 6 meter, into the value of D we have is 50 centimeter, which can be written as 0.5 meter divided by D. So this meter is cancelled out by this meter and 1 meter is remained. Now the value of D we are getting as 100 into 0.5 into 0.5 into 10 to the power minus 6, and on solving we are getting the value of D to be 25 micrometer. So this is the value of D we are getting between the two silts. This is the value of D. Therefore, option B is the correct answer of this problem. Thank you.
In the Young's double slit experiment, using a monochromatic light of wavelength lambda, in the path difference in terms of an integer n corresponding to any point having the half the peak, here it will be peak intensity of. So peak intensity, if we are taking peak intensity I naught, it means half the peak intensity, it will be I naught by 2. So we need to calculate path difference delta x at intensity I naught by 2. So firstly we will use the formula of intensity at any point. Intensity at any point is calculated by using formula I is equal to I naught cos square phi by 2. And they have given the intensity at that point is half the peak value, means I naught by 2. So I is equal to I naught by 2 is equal to I naught cos square phi by 2. I naught will cancelled out here, so we will get cos square phi by 2 is equal to 1 by 2, and cos phi by 2 is equal to 1 by root 2. Cos theta, it gives 1 by root 2 at 2n plus 1 pi by 4. So here phi by 2 will be equal to 2n plus 1 pi by 4. At all these values, cos theta will give 1 by root 2 value. So now we will use phi. Here phi will be equal to 2n plus 1 pi by 2, because this 2 will cancel out this 4 by 2. So phi is equal to 2n plus 1 pi by 2. But we need to calculate here path difference. How path difference is related with phi? Delta x is equal to lambda by 2 pi into phase difference phi. So what will be delta x here? Delta x is equal to lambda by 2 pi into 2n plus 1 pi by 2. And what we will get here? This pi will cancelled out, so it will give 2n plus 1 delta x is equal to 2n plus 1 lambda by 4. So path difference in terms of integer is 2n plus 1 lambda by 4 here. So here which option is correct? Let's see. This is 2n plus 1 lambda by 2, incorrect. 2n plus 1 lambda by 4. So option B is correct here.
तो यंग्स डबल स्लिट एक्सपेरिमेंट में जब ग्रीन रेड ब्लू लाइट यूज़ करेंगे तो उसके हिसाब से अपने बीटास क्या होंगे, ठीक है, बीटा मतलब फ्रिंज विड्थ। तो ऑप्शन को ये रिलेशन जानना चाहिए पहले कि लैम्डा मतलब वेवलेंथ ऑफ रेड लाइट इज ग्रेटर देन वेवलेंथ ऑफ ग्रीन लाइट इज ग्रेटर देन वेवलेंथ ऑफ ब्लू लाइट। जीआर में जैसे जैसे नीचे आते हैं वैसे वैसे लैम्डा बढ़ती जाएगी। सो अपनी बीटा जो है बीटा इक्वल्स टू लैम्डा कैपिटल डी बाय स्मॉल डी होता है, मतलब बीटा इज डायरेक्टली प्रोपोर्शनल टू लैम्डा, मतलब जितनी ज़्यादा लैम्डा होगी उतनी ज़्यादा बीटा होगा। सो डायरेक्टली इस रिलेशन में लैम्डा को निकाल दे, बीटा सब्स्टिट्यूट कर दो, ठीक है। बीटा रेड ग्रेटर देन बीटा ग्रीन ग्रेटर देन बीटा ब्लू, बस ये हो गया बीटा रेड बीटा ग्रीन बीटा ब्लू। फोर्थ ऑप्शन अपना बहुत सही है।
A biconvex lens of focal length f forms a circular image of radius r of sun in focal plane, then which option is correct? तो मेरे पास एक सिंपल सा एक लेंस है जो उसने बोला है बाई कन्वेक्स लेंस. सो सपोज मेरे पास एक बाई कन्वेक्स लेंस है. नाउ of focal length f forms a circular image of radius r of sun in focal plane. इट मीन्स हमारे पास जो इसकी रेडियस होगी, अगर सपोज करता हूँ यहाँ पे कुछ इस हिसाब से केस बनेगा. अब कोई भी हमारे पास जो रे है जो उसके सेंटर से पास करेगी, सो यहाँ से यहाँ तक का, तो इस केस में जो उसकी रेडियस होगी वो इक्वल होगी उसके सेंटर के. सपोज कुछ इस हिसाब से होगी. इसको हम दोबारा ड्रॉ करते हैं कुछ इस हिसाब से. नाउ अब हम देख सकते हैं इसमें कि जो यहाँ से यहाँ तक का जो उसका पर्टिकुलर डिस्टेंस है वो हमारे पास क्या है f. तो अगर मैं उसकी लेंथ की बात करूँ, सो लेंथ कितनी होगी मेरे पास यहाँ से यहाँ तक की, जो r है रेडियस के इक्वल, सो r. सो सपोज करते हैं अगर ये एंगल मेरे पास थीटा है तो यहाँ मैं देख सकता हूँ कि जो मेरे पास टेंजेंट थीटा होगा वो इक्वल है r डिवाइड बाई एफ के. सो यहाँ से हमारे पास जो r इक्वल होगा वो इक्वल होगा f टेंजेंट थीटा के. तो इट मीन्स यहाँ पे जो फोकल है, अगर मैं एरिया की बात करूँ तो एरिया हमारे पास क्या आएगा, पाई. मीन्स फर्स्ट मैं यहाँ पे करता हूँ स्क्वेयरिंग बोथ साइड. स्क्वेयरिंग करने के हमारे पास यहाँ पे क्या आएगा, आर स्क्वेयर इज इक्वल टू एफ स्क्वेयर टेंजेंट स्क्वेयर थीटा. नाउ मल्टीप्लाई विद पाई, सो हमारे पास क्या आएगा, पाई आर स्क्वेयर इज इक्वल टू एफ स्क्वेयर टेंजेंट स्क्वेयर थीटा. तो यहाँ से हम देख सकते हैं कि जो एरिया है डेट इज पाई आर स्क्वेयर वो डायरेक्टली प्रोपोर्शनल है एफ स्क्वेयर के जो फोकल लेंथ है. सो इट मीन्स हमारे पास का ऑप्शन आएगा ऑप्शन नंबर सेकंड.